Hello everybody, and today I'm going to be talking about transformations on exponential graphs. So the way that this works is that first you need to set up a parent function. And with the parent function, it's always going to be f of x equals 2x. And the way that you can figure this out is, double check it. You just hit 2x like so, and you hit graph. As you can see, it goes up, and if you want just to be, extra, you can always just plug in the points. So 0, 1, 1, 2, 2, 4. There we go. So that's going to be the parent function. Now, the way that we're going to tackle this is that the points are, 0, 1, oh, there, 1, 2, and then 2, 4. So we can draw that out like so. Now, the problem that you may encounter is that it asks, name 2 transformations. All right. So some of the transformations that we can go about, to add on to this graph is maybe moving it up a couple. So we can move the first point up by 2, and then moving it left or right. Or you can move it down, left, right, it doesn't really matter. But some of the things that you might have problems with is, writing it down. So let's imagine that we're gonna put another graph right here, and then it goes up to like so. It goes up to and about. All right. So we see the points right here. Now, the new ordered pairs, or the points that we need to look at, are now on the new graph. So 1, so right here it's going to be 0, 1, but for the new graph it's going to be 1, 1, 2, 3, 4. So it's going to be 1, 4, 2, 6, 3, and just based off of, what we have back here, it's safe to assume that this is going to be 8. All right, so now that we have the new graph, we have to figure out what the heck just happened. So when it comes to, here, I'll add in 0 for good measure. So 0, 3. There we go. One big happy family. All right, so 0, 3. So the way that we can look at this is that the way that I go about it is that I always find the points that are, similar, the points that were the difference between these two being moved. So the way that we can go about it is count how many times it's gone up. So 1, 2, 3, up 3, and then how many times left or right, and it's going right 1. Now it looks like we're done, right? No, we first have to figure it out with the parent function. So f of x equals 2x. Now we have to plug in up and right into this. So the way that we plug in right is that it's going to be 2, then we're going to make a parentheses. Now, since it's going right, you might think that we have to put plus, and then whatever numbers. But since it's going right, we actually need to make it subtract. So it's going to be right 1. So we're going to make it 2 minus 1. Then add in the exponent from right here. And then we have to add up 1 plus 3. So f of x equals 2 minus 1x plus 3. And that's how you get the new graph. Now, what if it's not asking you to name a transformation, but a reflection? What about that? Now, the way that you can go about it, you get your standard graph right here. Look at that bad boy. All right, but now since it's a reflection, the points are flipped. So now you got this. Now the parent function is the first thing that I drew. Now the transformation is going to be the other way. All right, so when you have something like this, you know, the parent function is going from, or the parent function is going to be reversed. So instead of having f of x equals, 2x, all you have to do to flip it across the y-axis is to take that x and put a negative right there. That's all you have to do. Now, you can double check this by going into the y equals and putting 2 going up here, the negative, and then x. Once you plug that into your graph, you can see that it is now flipped. Instead of it going up and to the right, it's now going down to the right. So there you go. That's the reflection and placement position transformations for exponential graphs.